Welcome back, and here we go with chapter 4. We're going to get some real chemistry. The starting picture shows someone using a magnifying glass, but of course atoms are too small to see even with a magnifying glass or a microscope. This is a document that will look slightly different because I had to remake it for Google Docs, but the gist is the same. There's a few things for you to fill in along the way, or you can take notes on your own. First thing we need to start out with is the definition of an atom, the smallest particle of an element that retains its identity during a chemical reaction. It is the components of everything. Don't never trust an atom. They make up everything. A long time ago, like forever, people have tried to figure out what stuff is made of, and there's been a lot of different ideas, some of them pretty crazy, but we have been tweaking our idea of the atom for about the last 200 years, modifying our theory, but never changing. It's not questionable that atoms exist. We just change what we know about them as we learn more and do more experiments. It's kind of a creepy picture, but this gentleman, Democritus, was an ancient Greek philosopher. There's lots and lots of stories about how he came up to his ideas. Around 400 BC, he proposed the idea that matter could not be divided indefinitely. In other words, if you chop something up, chop it up, cut it in half, cut it in half, cut it in half, at some point you're going to get down to the little tiniest bit of stuff that you can't break apart anymore. And he got in some trouble because he proposed that people's souls were also made of atoms. So in ancient Greece, they didn't really care, but once Christianity took hold of our governments and stuff, and every part of life, they got really upset with his idea about soul atoms and sought to burn and destroy all record that he ever existed. Fortunately, someone found a poem, which is not really poetry like you and I know it. It's not like a roses are red thing. It's more like a big long story that talked about Democritus, and he really fell out of favor because Aristotle was the guy for everything, and Aristotle didn't buy into this atom stuff. So Democritus' idea had this vision of atoms and a void, nothingness, and again, that kind of disappeared after him. Democritus, about 50 years later, said that matter was made of just 4 elements, and different beings, different things had differing quantities. So we're a big mixture of fire, earth, water, and air. Of course, Aristotle was wrong, but because he was such a smarty pants and became so popular, his theory persisted for a long time. Democritus believed that atoms were indivisible and indestructible. That's the word atomos in Greek. And of course, neither Democritus nor Aristotle actually had any evidence. They were just hypothesizing and talking eloquently. They didn't have a real explanation. From ancient times till about the 1600s, there were individuals called alchemists working, doing crazy things in laboratories, making our equipment that we use. Looks like they're throwing a little kid into the vat here, but maybe not, I don't know. All sorts of, they're selling their children to them so they can experiment. I don't know. It's really creepy. Anyway, they developed a lot of the equipment that we still use, as I mentioned previously. It took an English school teacher in Manchester, England, to come up with the beginnings of modern atomic theory. John Dalton probably didn't know about Democritus, but he came up with some concepts that you'll need to know. Through his work, and he actually did some experiments, he proposed that matter is made of little tiny particles, and he used the Latin or Greek atomos, atoms. He also proposed, in addition to matter being made up of little bits, that atoms of the same element are identical, which is almost true. They do share characteristics, of course, and every kind of element has different kinds of atoms, which is also true. He said that different elements can physically mix together, true, or those same elements can chemically combine in some whole number ratios to form compounds, also true. Finally, he proposed that chemical reactions occur when atoms are separated, joined, or rearranged. And again, that's also true. So he's got the foundation of atoms, the atomic theory, pretty clear. And of course, we know that atoms of one element aren't going to change into another element in a chemical reaction. Now, that's not true of nuclear reactions. We'll be talking lots more about that. So, instruments that we use to view atoms were developed in the late 70s, early 80s. A couple of gentlemen, I think they're from Sweden, got the Nobel Prize for that. And the instrument's called a scanning tunneling microscope. Super cool. It's not really using light. It's not using light. It's using electric current, and because the outer part of atoms is negative due to the electrons, if they run a negative charge at the tip of this little pen thing, it will trace over the top of the atoms, and because it's repelled. So kind of like running your fingers over something in the dark, you can tell what the shape of something is without seeing it. That then gets put into a processing unit to create a display for us. And they can change the voltage, they can change all sorts of things, but they can literally trace over things. Kind of like doing leaf rubbings, with crayons back in the day. Put the leaf under the paper and rub over it, you get the image. This is what they did to prove that they weren't making stuff up. So just the same way that you can repel with like charges, you can attract with unlike charges, and they can lift up atoms and move them, manipulate them on a surface. And they spelled out the classic IBM logo. They were working in IBM's research labs, and it's pretty cool. This image is in your book. It's showing iron atoms. Again, the images, the scanning tunneling microscope is going over the top. Pretty cool. I'm going to put links to this. I really want you to watch this. This is super cool. Actually, I may play it in class today. It talks about how they developed the SEM, how they're still using it, and how much we're all benefiting from their research. And then this is just a silly thing that they made, a boy and his atom, to show that they can move things around and make a little movie. Copper pennies, this is just one of the questions in the assessment, so you might want to look at this. Copper penny has 2.4 times 10 to the 22nd atoms of copper. That's a lot. I think this actually needs to be over 7 now. We've got 7 billion people on Earth. There's more atoms in this penny than there are people on the planet, which is kind of crazy. And it would take 100,000 copper atoms side by side to just measure 1 centimeter. Okay? It's kind of crazy. We're going to get into next how they do subatomic research. This is a joke, of course, with that chopping things in half idea. The biggest research right now is going on at CERN. It's at the border between France and Switzerland. It's a 17-mile around tunnel with another smaller tunnel linked into it and some other buildings all underground. It's just crazy. It is a joint effort of many, many nations of the world, including the United States. and they've been doing some fun stuff. This is a particle accelerator or an atom smasher. To give you a feel for the size, the building is, the tunnel, excuse me, is 3 stories, would fit a 3-story building inside of it. And this is just some of the equipment and some of the people that worked on it. Here's a man right here inside one of the areas of the Super Collider. These tunnels on these pipes are where they run the electric current and the particles through. And then there's a short clip on CERN and what we have learned. It's a couple years old, but it's still pretty cool. And that, my dears, is it for today.